All right. Let's see. Yeah, so the first thing I guess is some updates on Metalhead. So kind of like we discussed last time, what I did is I basically used the, oh, thanks, Lorenz, the agendas in the chat. Yeah, so kind of like we discussed last week, there's a Metalhead PR. Let me just grab the link to the PR and send it to everyone. But basically for that, what I've done is taken the pre-trained weights from the old version of Metalhead and transferred them over to the new model. So it's just a little bit of manual translation, worked out fine. I'm uploaded the pre-trained model files to a Dropbox folder that I shared with Daria. He's going to host them either on Git LFS or just on the Julia computing server somewhere. Once we have that, there's just a couple last minute cleanup things that I need to do to make the whole package artifact system download those weights and load them, easily into the models. And then I think that PR is ready to go from a draft into a, PR for review, hopefully within, a week or so. Since that, I think PR has been there for a while, people have had a chance to look over the code. So hopefully in a week or so, we'll have the new version of Metalhead, in which case we can start using it for FastAI and whatever downstream packages we need to.
That's really cool. Do you have a list of, or is there a list of the models that have pre-trained weights now?
So it'll be the same as what was in the old Metalhead. So that includes VGG19 without batch normalization, ResNet 50, GoogleNet, SqueezeNet, and then I think one of the dense nets. I don't remember which one. So I mean, at least in terms of coverage, I think in type of model and model size, that will be good. And then we can, kind of like we discussed last time, training these models and slowly adding pre-trained weights for the rest of them will be a good test of our overall packages in the pipeline. So, as we make changes to FastAI and Flux training and the like, we'll slowly add pre-trained weights. And yeah, hopefully all of that goes smoothly. Yeah, I mean,
and then this also removes the everything but the models, right? Like the console visualizations.
Right. All of those dependencies are gone. I think the only dependency is going to be Flux itself and Flux and BSON to load the weights. And yeah, all the package really provides is the functions with the exact same names as the models listed in the PR, and that's it. So there's nothing else in there.
That's really cool. Then we can plug that into FastAI and then have a, because I was working on the fine-tuning code, porting it over from FastAI with freezing and fine-tuning pre-trained models, but I didn't have a pre-trained model to test it on. So
yeah, I mean, I can share with you the link to the Dropbox. I mean, if you want to start testing now, there's at least VGG19, so you could use that as a pre-trained model. I still have to upload the other BSON files, but they'll show up there in a day or two, hopefully.
Yeah, I can wait that long. VGG is so slow anyway.
Yeah. right, well, yeah, since we started late and there's actually a lot of stuff on the agenda, I'm gonna keep moving unless anyone else had something on that topic. Okay, in terms of the data sets, I mean, I guess, Lorenz, you already know this because you were pinged on that PR, or you're the one who suggested it, but we're moving the FastAI and the DL datasets into ML datasets. So this is just going to be like a cold fusion. Basically, anything that was already in ML datasets, you'll access through what already exists in ML datasets, and anything that we're adding in, you'll access through whatever API we currently have. We're not necessarily, the first merge won't necessarily refactor the entire dataset API. But I think the long-term goal is to refactor the API to look something like the datasets in FastAI. So there's a link to that in the agenda. I can grab it and post it in the chat as well.
I also put the issue from DL datasets.
Thanks. Yeah, so I mean, I think long-term, probably the overall API of ML datasets will look like, I guess, 3 tiers. The lowest tier will just be the learn base. And number of observations, get observation functions. So those 2 functions will basically be the lowest level interface. Any struct that implements that counts as a data set. But then the mid tier on top of that will be something like what's in the FastAI right now, where data sets that can be read in through some, kind of generic mechanism, like a file tree data set or something like that. You'll be able to use that mid tier and just specify the locations on disk for the data set, and any kind of parameters about the encoding, and then it'll read it in. And then, the highest tier will obviously be the standard data sets implemented. Hi, Brian. Implemented using the mid-level tier. So that should be pretty good, I think. I don't know about FastAI, but at least PyTorch provides basically a generic folder data set, which works, if you download some data and you do some pre-processing, then you can make it fit into that folder data set system. But other than that, you're kind of writing your own data set from scratch. I think if we have this mid-tier that supports a bunch of different kinds of mechanisms for reading from disk generically, it'll make this entire thing a lot nicer.
Yeah, and I mean, reading from disk, there's also a plan to put in a support for abstract tables datasets. So reading those as a data container, and then so that's the different containers, and then also different transformations, which you can also find on the link in the chat, like grouping, splitting, joining data containers, mapping functions over them, and then those allow basically creating data sets really, really easily.
Yeah.
Sorry, I couldn't hear you. Are you talking about for tabular data sets? Like you said, grouping and stuff over abstract tables? Over tables that
no,
data
there's just functionality for reading any abstract table as a data container, so that nops and getops is defined, and then the grouping is to that's just one like data container transformation where you split.
Yeah,
you split a data container into different groups.
Right. So there is that shouldn't be in our package ecosystem, right? Isn't there generic table operations or something we could use for that?
No, but it's the transformations are generic on data containers. And
Right,
then
so
the tables wrapper is one implementation of a data container.
Oh, okay. Okay, gotcha.
So there's also a data container that's called currently file dataset, which wraps a file tree from filetrees.jl, but you can also apply the grouping transformation to that, for example. I'll send the exact file in the chat, the transformations. If you want to have a look at it.
Actually, filetree.jl was going to be my next comment, but as usual, Lorenz has it covered. So okay.
yeah, I think all the transformations like grouping, splitting, that kind of thing, the idea is for it to be generic on any kind of data set, regardless of how it's actually stored in memory or disk.
Yeah.
And we can if there are table related functions that make that efficient for tabular data sets specifically, then we can specialize always on the dispatch and use those functions as the underlying mechanism to group them. Yeah. Yeah, unless anyone had anything else on data sets, we can
just
move
for those
on.
data, I said that I'll open a merge request in DL datasets and ML datasets, which dumps the code in there.
Yep. Okay. Yeah, so I got to look out for that PR if you're interested in helping with that effort. But otherwise, we can move on to the whole ML data pattern, the whole ML data star situation. Yeah, so I mean, I started that process a long time ago, and it's like one of those things that I work on, one weekend every now and then. It's just like a slow, time-consuming process because that code base was written really long time ago, and there's a lot of nice things that we have in Julia now that wasn't available then, in terms of having a flexible interface that also is performant in terms of type inference. And so there's a lot of extra boilerplate code in there that, it's hard to figure out the exact dispatch path that's being followed. But I think for the most part, I've gone through all of it. I'm fairly confident. I mean, I've already done that for ML data pattern. I'm doing it now so the only thing in ML data pattern that's left over is the get target, which gets the Y label for each of the, for whatever data container you're using. And so that relies on ML label utils. I think I've finished refactoring ML label utils. There's a couple tests though that I'm still trying to figure out what exactly is being tested there and how I'm supposed to fix the test so that it works after the refactor. But most of the test cases are passing. So probably there's already a PR out for LearnBase. I'll submit a PR soon for ML label utils. And then I guess there'll probably be maybe a week or not a week, probably more than a week or so of lag time before I get around to submitting a PR for ML data pattern. But I think the plan with all of that is to submit PRs for all three. And once we can verify that the refactor of the interface in LearnBase works in both data pattern and label utils, then we can merge LearnBase and then merge label utils and data pattern. So that's kind of the overall development path. Once that's done, of course, we need to update some of the stuff we were just talking about. Like, I don't think really any of our packages use the observation dimension, but I guess now that the whole idea of the observation dimension has been refactored to not be that whole type system, we probably should start adding that into our packages. And then the
How
other
does
thing,
it work now?
I mean, it's kind of like the dims keyword on almost any base function. So previously, yeah, it used to be a specific type in order to be efficient, and used a bunch of generated functions and things like
Yeah.
that. Now that's basically eliminated. You can get equal performance just passing in a number. Yeah, so
Is it multiple dimensions or still just one?
it's still just one dimension. Yeah, I mean, it's not limited necessarily in terms of its type at all, so it doesn't have to be an integer. But I guess I got to think about whether it would work over multiple dimensions. It's possible we can just do that. But it really just depends on what is the data structure that you're indexing into, right? So,
Yeah.
And most of the functionality that's in ML data pattern really only applies to tuples and to abstract arrays. So in that case, it's just an integer. But if it was some, I don't know, other weird thing like a symbol into a table, I guess it could be that as well.
And how do you specify the last dimension? Because that's something I stumbled upon in dataloaders.jl. I was also thinking of introducing like a concept of like batch dimension, because you want that for the data loaders. And also if you want to split the batch into views of slices again. But then if you only have integer dimensions, that's kind of hard to do.
So I guess I didn't understand the part about if you only have integer dimensions.
Sorry, I mean, if the keyword takes values like 1, 2, and 3, how do you specify like in a general way the last dimension? Is it like -1?
Oh yeah. So that, I mean, by default, for an array, ML data pattern would assume that it's the last dimension. But if you want to specify for an arbitrary data container, there's a default obsdim interface that you can extend or override.
Okay.
Yeah.
That reminds me, I don't know if this is a tangent, too much of a tangent, but the RNN data input design, where I think it's a vector of observations as opposed to like what was it in PyTorch, like a 3D array or something like that. Can we make that work with this? And also, are we leaving performance on the table by having that kind of data structure, like as opposed to just a multi-dimensional array? Like, is there issue with CUDA NN that won't work because of the way because of our input data structure?
Yeah, I mean, I know that's like yeah, I mean, the short answer is yes, I guess, but I know that's a thing that has been discussed on GitHub, you know, whether to use cuDNN or to use CUDA. And I think the latest that I've seen, so I think right now we don't use cuDNN anymore. The latest PR out there drops support for cuDNN. But I think in the end, cuDNN still has the higher performance. I mean, maybe Brian can comment more on it, but I don't know too much about the whole RNN situation in terms of the performance.
I'm sure this has been considered, obviously, but it wouldn't be nice to have like a specialized code path for cuDNN, and then you can customize that.
I would rather we figure out the API side of things first. I think if you're going to, because before what was happening, as if I remember correctly, is that a lot of ceremony was required to get the data into a form which cuDNN liked. And really, at that point, if you're passing one time step at a time to cuDNN, I don't know if it's really optimized for that. Frankly, I don't even know why the design was made the way it was in the first place. Maybe it was conceptually interesting, but practically it's been in us again and again and again. So I think for a subsequent meeting or designs discussion, we should talk about 3D inputs. I think we should have Jeremy on the line for that though, because he is the RNN guy and I am not.
Yeah, I agree. He would be the one who would know exactly how to answer your questions. Though I do know that one thing you can do with the whole vector of time steps format is you can broadcast on a bunch of time steps at once, or you can broadcast your model across the time steps. So maybe, a way to resolve the issue is to specialize the broadcast rule to go to something like cuDNN, where it's optimized for a situation where you're operating on many time steps, in a dense data format. And then that way we can still support the mechanism to go one time step at a time.
I just don't see the utility of going one step at a time, frankly. Like I think there is some conceptual clarity in it, maybe some pedagogical value in that this is what the RNN is doing under the hood. But what is the point? I mean, like, if you want to go one step at a time, you can just unsqueeze your sequence into a time step length 1 3D tensor.
Right.
Whereas the other way around is much more difficult.
Yeah, that's a good point.
Again, I don't know. I mean, like there must be, I don't know the motivation for this, so there must be some. And without that background, it's kind of like groping around in the dark, trying to figure out why it was made this way. But seeing how many questions we have about this, it's starting to get a little, I feel like the empirical evidence we have so far is saying that it is not a very friendly abstraction.
Yeah, I mean, though, I'll be honest, I think part of that is like a documentation issue too. I mean, if you look at the RNN docs for Flux right now, it reads more like look how easy it was to implement RNNs in Flux than this is how RNNs in Flux works for a beginner. These are all the standard things you might try to do, and this is how you do them. So
and maybe that was the motivation for design, honestly.
Well, the dev docs were updated recently, but they're not obviously. I don't know if they were meant to be part of O.11. something, and they got missed out along with the other commits, or if they're meant to be part of O.12, and they just haven't been published yet. But the latest doc site has Jeremy's updated docs, which are much nicer.
Oh, that's good.
Yeah. And dark mode.
Yeah, I mean, I guess kind of related to that, I did have linked in the agenda time series data. So I think ML data pattern also does the same thing right now with time series data, where it doesn't do a good job of compacting together the batches of data when you apply something like sliding window or something to the original data set. So if the original data set is compact with respect to time, and you apply a sliding window to it, and it's tuples where it has a input and then a target, then ML data pattern will just like splice the entire thing up and destroy any density that you had. And so I think we need to kind of go through that as well, even on the ML data pattern side. So probably, I guess, once Flux has API that makes sense, we can do kind of the default thing in ML data pattern that works well with Flux.
Okay. Also, are we going to talk about optimizers and the immutability thing? I'm confused about that.
I mean, I can give a brief summary. I wasn't planning on talking about it today, just because
Did you and Daria come to an agreement?
We came to a path forward, I think. I think there's just healthy disagreement about well, I think everyone in the end agrees completely that we should have immutable optimizers. They're easier to write the code for, like write the optimizer rules for, and they lend themselves really well to optimization, by some kind of compiler like tool, right? Like XLA or whatever. And so, yeah, I think everyone wants it to be immutable. I think the disagreement is about whether we can feasibly do that now. Or I guess the disagreement is right now we would like to have explicit state as part of the optimizer. So at least I'd like to bring explicit state into the Flux optimizer scene so that we can start building interfaces for scheduling and things with that solid API in mind. Because it makes the entire process of designing those interfaces on top of the optimizers or to coexist with the optimizers much simpler. But right, so I mean, what the disagreement is basically just about the deprecation path. Do we just go with immutable optimizers and explicit state, make everything breaking, and how much performance would be left on the table if we were to do that? I mean, the short answer is I don't think we're going to end up doing that anytime soon. I think what's going to need to happen, which is this current agreement that we're at, is that we test what's on optimizers.jl's master against a mutable version, which is on another branch. I can find, Daria has another branch, so I can find that branch and send it to you or send it to the chat. But there's another branch that has the mutability in there. And so we compare the performance of those two, and then based on how much performance we lose, I guess we can make a decision about what the deprecation path should be. I don't know, is that the summary you were looking for?
Yeah, that makes sense. So why can't shouldn't the immutable optimizers be, I don't know, back allocated when you update them?
So it's not the optimizers themselves, it's the intermediate state you get when running the optimization. So when you look in the inner loop of Atom, for example, you have those intermediate variables, which are all arrays. And generally with the mutating versions, you could reuse buffers. Most importantly, you could reuse the parameter buffers. So say you allocate, your parameter is like 100 by 100, you allocate a momentum array of that size for it. You can update that in place. Whereas with the immutable interface, you have to allocate essentially another array of the same size and return that. So the question is, I mean, at this point, we're relying on the immutable version relies on two things. It relies on the GC being smart enough, especially when it comes to GPU memory. And it also relies on the compiler being smart enough to perhaps optimize away some of those allocations. But I don't know how much it can do without some like larger program analysis of like where the optimizer is being called and all that stuff.
Gotcha.
Yeah, and I think if we look, like once we have the metalhead PRs and stuff that I talked about, it'll make doing that kind of testing a lot easier in terms of scaling up the model size and seeing how like the GC and the compiler and stuff can keep up. Because
Cool.
for a more complex optimizer rule like Atom or something, your worst case allocations are going to be for every parameter you would allocate, for every parameter in the model, so every weight in the model, you would end up allocating, your first and second moments, which are arrays of the same size as that weight array. And then the gradient updates, the gradient transformation also can't happen in place. So then you'd also need to allocate for a gradient array, which would again be of the same size. So, it's like a 3x worst case if nothing gets nothing gets reused efficiently or optimized away.
Got it.
Right, and I guess one thing I should mention though is that currently with optimizers, .jl, it is possible for the GC or the well, yeah, I mean the compiler thing is a separate issue, but it is possible for the GC to keep up because it's not like, I'm pretty sure optimizers, when it uses functors to update all the leaves of whatever data structure it is that you're trying to update, will not literally make a copy of the entire model, all at once, right? It does it in steps with each leaf, right? So you can, as you move from leaf to leaf, play, some level of catch up. And not pay, the full allocation penalty.
Yeah, I think the bigger question is not necessarily the native GC, but the CUDA allocator. If that is able to handle the frequent allocation, deallocation. I know there is some degree of caching, so perhaps it can, but I don't know. We'd have to quantify that. I remember it was the whole allocation issue was a bit of a pain when we were looking at that convolutional neuro ODE, if you remember that. So I don't have high expectations for it dealing with high amounts of allocation in series.
Okay, well, we're almost out of time, but let me quickly do this. I'm gonna try to get through as much triage as possible. Because we're actually test running this, I think, in earnest for the first time. These are actual stale flux issues. The first one, which I just sent to the chat, is pretty simple. Someone just needs to update that markdown file in the docs. I don't know. I feel like the easiest thing to deal with this triage issue is one of us just agrees to submit a PR that updates that doc. Then we can just close this. which of course I guess I can do. So I think that gets rid of the first one. Let's see, what was the second one? I guess this is related to a certain this is related to a certain extent to what we were just discussing in terms of the RNN stuff, right? We wouldn't need this masking layer with the whole vector of time steps approach that's already in there. But I guess we would need it if we turned it into something that's more dense. Is that right?
Well, I mean, I don't know what the Keras masking layer does, but if, for example, you have a multivariate time series and only some variables are missing at a given time step, you still need masking. It's a big part of stuff like the DRU decay, DRUD, and other models. I don't know if that's what the Keras layer does, but I think Mike's comment on there where saying you can just not pass the time steps that are missing observations is incorrect, because there are cases where that assumes your time steps are only have one feature, or that all features are simultaneously either there or not there.
Right. I mean, at least my reading of the Keras masking was that is how it worked as well. It was on a time step level and not by features. But I mean, I guess regardless of whether that's what masking in Keras does or not, if there is a use case where you do need to mask certain features per time step, then I guess this is not an issue that we can close, and probably a layer that we want to support somehow, or not necessarily a layer, but some mechanism that we need to add for it.
Yeah, I will, I guess I will look through the masking and get back on there. Push comes to shove, we can just repurpose this as have a way to mask certain variables in time step.
Yeah, I mean, I guess I know exactly how we want to implement it, but back when I was thinking about doing the whole pruning stuff, the way I was planning on doing some of it was to introduce a type of masked array, you know, where, I mean, it would basically behave like a normal array except with the mask, and just introduce a new array type. So maybe that array type would be helpful here as well.
I think so, yeah. That feels like a more elegant approach to this rather than creating a layer for the mask. I looked through it and I still don't really see why you need a layer specifically instead of just having a masked array.
Right. Yeah, I mean, I think the fact that it is a layer specifically is definitely a Keras implementation artifact if you read through the Keras page on it. Okay, well, I guess I'll move that, I don't know, into some kind of low medium priority column.
Yeah.
And comment on the issue. Okay, I guess the next one is related to gradient algebra. I mean, I know that the general mentality, I think, with Flux is to not mess around with params or grads, because it's, you know, so intertwined with everything. But at least to me, there doesn't seem to be any harm to just forward, some basic operations like addition, multiplication, things like that into the actual data inside the grads or params objects.
Yeah, I agree. What I was wondering though, of course, like simple addition and the arithmetic operations, you can implement them, but for performance, might make sense to make those in place. So, I mean, the use case that's being discussed in the issue is gradient accumulation, where you calculate the gradients for an optimization step, but you then don't update it. Don't make the step just yet, but you accumulate the gradient for some number of steps, for example, to simulate larger batch sizes. And I think in that case, I'm adding the gradients of like the following steps in place would be more performant. Maybe it's a non-issue, not sure.
Yeah, I don't know.
One difficulty I see is that currently the only way to index the grads struct is via ID, via parameter ID. So, oh wait, oh I see, oh wait, oh it stores a params then, okay. So you could, so if we're talking about overloading, yeah, I mean ideally this would be like you would zip new grads and old grads and then you would, dot plus equals new grads, whatever thing into old grads thing for thing in params. I mean, like it's possible to do by hand now, but I guess you're saying put an overload for the entire grads object in Zygo itself?
Yeah, I mean, I think it's possible to do iterating. You don't need to know you don't need to zip up with the params, I don't think, to iterate through all the gradients. But yeah, I think what I was thinking is that we would overload maybe broadcasted addition and multiplication, or at least the way I was thinking about it is that if you had two gradients and you broadcast one of these operations on the sets of gradients, then that operation should be pushed all the way down to the actual arrays themselves, which if we can make that mechanism happen, then I think the in place versus out of place issue might be taken care of by broadcast fusion, right? So as long as you do a dot equals when you do the addition, and the thing on the left hand side and the right hand side is the same array, it should do it in place.
So you basically need like an in-place mapping function over two grads objects, and then the overloads for broadcasting, right?
Yeah, I mean, I don't think you even need the in-place mapping function. I think you just need...
it might make it easier to write like plus minus multiplication.
Oh, if you had a map. Yeah, I see what you mean. Yeah.
That's just from the implementation side, yeah.
Right. Yeah, I mean, that makes sense. I mean, yeah, if you're going to support broadcasting, you should probably support mapping. Just mapping in general, right? And then the broadcasting, the addition can be a special case overload.
Yeah.
Okay. Yeah, that sounds like a good plan.
I mean, yeah, bye, Ari. Nice to go. I'm not familiar with the overloading broadcasts, but probably shouldn't be too hard, right? So I can take a look at it.
I don't think so. I mean, there's just like a function called, I think it's either broadcasted or broadcastable or something in base. And the first argument is just the type of the operator. So it'll be like type of plus. And then the following arguments are the type of the actual things, the objects that you're broadcasting.
Yeah.
So it is pretty simple to overload it. Okay, that sounds like a good plan to me. I guess. Let me post the last one then. So this one basically has to do with type promotion. I mean, this is something that bites a lot of people, where they have a mixture of float 32 and float 64 in their overall pipeline, and they pay a performance penalty as a result of that, or they have some dispatch issue. And right now the solution is basically to have a section in the docs that says, don't do this. You know, or if you're gonna write a function that has constants hard coded into it or something like that, here's how you make sure that those constants have the right type, that kind of thing. But I think in this case, what was suggested is that because the performance difference is so bad, we should have a warning whenever this kind of promotion happens. It's kind of easy to do for a specific layer like dense, where you can just throw a warning if someone tries to call dense with a mismatch input array type from the weight array type. But I think in general, doing it for any multiply that occurs in the model is, I guess, quite hard to do. I don't know. Lyndon posted some example code that he says compiles away. But yeah, I mean, I don't know.
Wouldn't this have to go in nnlib if you're intercepting multiply? Because nnlib does all of the layers just forward to nnlib anyways. Unless you would have to do something like, you'd have to use something like cassette if you wanted to intercept those without modifying them on the source level, which is its own bag of horrors. So.
Yeah. Yeah, probably. Maybe it should go in nnlib, and I mean, the issue with putting it in nnlib is that, okay, fine, it addresses, like, all the layers do dispatch to nnlib, except for like dense, for example, doesn't go to nnlib. But I think if you extend it in nnlib, since Flux depends on it, it should apply to anything inside Flux as well. Or like you can use the safety rail mechanism in Flux. Yeah, I guess, I don't know, maybe we could implement something like this, like a utility function in nnlib, and people could insert it into whatever code they wanted. I think the main...
Is the work worth the payoff, do you think?
I mean, I personally figure that if this is an issue with multiplication, then, and pretty much no one wants to use generic matmul from base, and almost, like, not just in ML, just in any code in general, you almost always want to hit BLAS or some kind of equivalent of BLAS if you're doing a matrix multiply. So to me, it seems more like a base issue.
Yeah.
But because if no one wants to use generic matmul, then maybe base should be the one that's warning people. Then I feel a lot happier about the entire situation. I think the thing that I don't like about it is if we were to put it in nnlib. What we could do is put in the safety rail mechanism, and then people could use the safety rail, but I'm not sure how that really solves the problem. But if you shadow just the multiply operator, the asterisk, then how do you prevent anyone that's not a Flux user that depends on nnlib from getting that shadowed version of multiply? I mean, technically it compiles out, but maybe they don't want the warning in their particular use case.
Yeah, I'd rather, if this is really about type promotions, breaking things or hitting a performance sad path, then I wonder if it'd be more fruitful to put in some mechanism to catch those type promotions and show them, kind of like we have for output size right now, something like that, except for type promotions.
Right.
Because intercepting multiply feels so, it's like this is not the right level of the stack to be doing that.
Right. Yeah, I agree. Something that's closer, something kind of like output size or the sanity check mechanism in Flux training. A simplified version of that just deals with type promotion would be, I think, a better way to solve this. Because at least then, it can handle custom functions and stuff like that. But it doesn't affect any of the forward, backward pass actual code. And we don't do any kind of weird type piracy. And then in terms of answering the question about Hessian vector products, I mean, I guess that's not a Flux specific thing. I don't know a lot about forward diff mode in Zygote. I think you can get the VJP out of Zygote, but I mean, if you want the Jacobian vector product, I mean, there are different AD tools in Julia that could allow you to get that. I just don't know how efficient they are. If that's the question. Oh, Hessian vector product. Yeah, I guess I don't know enough about the different AD tools to know which ones would allow you to get the Hessian.
Yeah, I think this would be a better question for maybe the autodiff channel on Slack or on Zulip, because this is entirely the domain of Zygote and chain rules. Flex only only calls the operations, so all of the rules for that are defined in the AD packages. And I know there's a VJP and JVP, but I don't know if there's like a HVP. So yeah, worth an ask on there. I know we were talking about Ada Hessian. I think it's useful there, but like this is not a Flux issue. Like we're working at one level higher in the stack.
Yeah. Yeah, I think the autodiff channel on Slack is probably the best place to ask.
Yeah, and they talk about stuff like this all the time. It always flies over my head.
Yeah. Yeah, I mean, I guess the easiest answer I can give you is that whenever Diffractor lands TM at some later date, it's supposedly more efficient for higher order AD. Oh, okay. Yeah, I mean, I think probably depending on how you plan on using the higher order derivative will affect the answer that you get. So yeah, definitely go to the Slack channel, post this paper. And I think the people over there will be able to answer your question most efficiently. Yeah, I mean, maybe you'll be interested in this following this particular discussion on GitHub, since you are asking about optimization loops that involve higher order derivatives. But yeah, I'd say ask your question on Slack. You'll probably get a quick answer. Sorry, we couldn't help too much more. Yeah, I guess if there's nothing else, that's all the triage issues that I had picked out for today. So we can call it a day and meet in 2 weeks unless someone had any last minute things to bring up.
Yeah, I register data augmentation and your pipelines.
Oh,
So,
okay.
Awesome.
I can, if the compat bounds of Metalhead are also being fixed, then I can also add that as a FastAI dependency. And then I think there are no unregistered packages left.
Awesome.
Flux v0.12, I think also has to be released. But yeah.
One last question before we end. Do you know, so you mentioned, Kyle, that you have pre-trained weights for the Metalhead stuff now. Is there somewhere I could see the code that works with those? Is that on your branch yet?
No, I mean, the idea is that we're not going to commit them directly to the repo, like the BSON files. There is a Dropbox. I mean, I can share the link with you.
Oh, that's fine. Oh, I thought it was like a new format, not the, so, okay. That's fine.
Yeah. You mean for the weights?
Yeah, I thought we had like a new approach of getting the weights that wasn't the old BSON files.
No, the actual, like the files themselves are just BSON files. The only thing that's changed is the loading mechanism. We'll use package artifacts, which will be on my branch. It's just that the weight files themselves won't be on the branch. They'll be hosted elsewhere.
Okay,
And that
gotcha.
I've sent the BSON files to Daria, so within the next day or two, he and I will figure out where we want to host them and put those up there. Okay. Well, I guess if that's it, then I'll stop recording